Welcome back for week 5, day 4. This is Mrs. Siebers again, and we are continuing to practice solving multi-step equations. Here are the answers for yesterday's homework problems. Let's go ahead and watch that video here.
Today we're going to go over the homework assignment from day 3. For the first question, what we have to do is to perform the distributive property to get rid of our parentheses. So I'm going to start off by writing everything down that I'm going to keep, which is my 129, the equal sign, and the 2x. I'm also going to keep my addition sign that's right here. And I'm going to multiply my 5 times my 2x. And that, because both numbers are positive, I can keep the addition sign, and that gives me 10x. Next, I have a positive 5 and a minus 3, a positive and a negative sign, or addition and a subtraction. And that's going to give me, since they're different, negative multiplication is 15. So I should have 129 equals 2x minus 10x, plus 10x minus 15. In doing so, I now need to check to see if I can combine any like terms. If I look at my left-hand side, there is nothing else to combine with this constant. But if I look at my right-hand side, I do have a 2x, positive 2x, and I have a plus 10 that I can combine together. So with that being said, I can now come down and say 129 is equal to, and 2x plus 10 more x's gives us 12x. And then I bring down my minus 15. Now, in trying to get my variable by itself, I need to actually go through and make sure that all of my constants are on one side and my coefficients with variables are on the other. So I need to move my minus 15 from the right-hand side to that of the left. And I do that by doing the opposite of what's there. So if this says minus 15, I need to be adding 15 to both sides. Remember, what you do to one, you must also do to the other side of the question. This forms a zero pair. So now I'm left with 12x is equal to 129 plus 15 gives me 144. Now, I still need to get my variable by itself. It's still connected to the coefficient through multiplication. So to get rid of it, I have to divide. I'm going to divide by that coefficient, which means I'm dividing both sides by 12. So now I'm left with x is equal to, and 144 divided by 12 gives me 12. Okay. For question number 2, I'm also having to do the distributive property to get rid of parentheses. And the easiest way to do it is to write it the way that you see it without simplifying first. So I'm simply going to multiply my numerators with the coefficient that I have here because I have to distribute it to both parts. So that's going to give me 2n divided by 4. And then I have a subtract. 1 times 28 gives me 28, and I'm going to also divide that by 4. That is all equal to 10. Now I can combine like terms if I have any, for which I do not have any for these problems, so now I need to simply simplify. So now I have 2/4 n, and if I simplify this, I get 1/2 n minus, and 28 divided by 4 is 7, equals 10. Now I need to actually move my constants to the other side because I'm still trying to isolate my variable. And I see that the constant I need to move is this minus 7. So the opposite of subtracting 7 is actually adding 7. And I will do that to both sides. So that leaves me with 1/2 n is equal to 17. Now, I have a division or a fraction that's in front of my variable that I needed to get rid of, and that represents the operation of division. So I do the opposite of what's there. I'm going to multiply both sides by my denominator, which is a 2. So I'm left with n is equal to 17 times 2, which gives me 34.
All right, today's objective states that given a multi-step equation, I will solve the equation algebraically and check my solution. All you need today is paper and a pencil. Again, here is that same vocabulary we've been looking at all week with equations and those properties of equality and those same pictorial representations that we have been looking at. Let's go ahead and take a look at our instructional videos for today. They are both examples of solving equations with variables on both sides.
Let's try to solve a more involved equation. So let's say that we have, let me think of a good, say we have 2x plus 3, 2x plus 3 is equal to 5x minus 2. So this might look a little daunting at first. We have x's on both sides of the equations. We're adding and subtracting numbers. How do you solve it? We'll do it a couple of different ways. The important thing to remember is we just want to isolate an x. Once you've isolated an x, you have x equals something or x equals something. You're done. You've solved the equation. You can actually go back and check whether that works. So what we're going to do is just do a bunch of operations on both sides of the equation to eventually isolate the x. But while we do those, I actually want to visualize what's occurring, because I don't want you to just say, oh, what are the rules or the steps of solving equations, and I forgot whether this is allowed or that isn't allowed. If you visualize what's happening, it'll actually be common sense what's allowed. So let's visualize it. So we have 2x right here on the left-hand side. So that's x plus x. And then you have plus 3. Plus 3, I'll do it like this. So that's equivalent to plus 1, plus 1, plus 1. That's the same thing as 3. I could have drawn 3 circles here as well. Let me do the same color. Plus 3. And then that is equal to 5 x's. I'll do that in blue. That is equal to 5 x's. So 1, 2, 3, 4, 5. And I want to make it clear, you would never actually have to do it this way when you're solving the problem. You would just have to do the algebraic steps. But I'm doing this for you so you can actually visualize what this equation is saying. The left-hand side is these 2 orange x's plus 3. The right-hand side is 5x minus 2. So minus 2 we could write as minus, let me do this in a different color. I'll do it in pink. So minus 2 I'll do as minus 1 and minus 1. Now, we want to isolate the x's on the same side of the equation. So how could we do that? Well, there's 2 ways of doing it. We could subtract these 2 x's from both sides of the equation, and that would be pretty reasonable, because then you'd have 5 x's minus the 2 x's. You'd have a positive number of x's on the right-hand side. Or you could actually subtract 5x from both sides. And that's what's neat about algebra. As long as you do legitimate operations, you will eventually get the right answer. So let's just start off subtracting 2x from both sides of the equation. And when I mean that, I mean we're going to remove 2 x's from the left-hand side. And if we remove 2 x's from the left-hand side, we have to remove 2 x's from the right-hand side, just like that. So what does that give us? We're subtracting 2 x's from the left, and we're also going to subtract 2 x's from the right. Now, what does our left-hand side simplify to? We have 2x plus 3 minus 2x. The 2 x's cancel out, so you're just left with the 3. And you see that over here. We took 2 of these x's away. We're just left with the plus 1, plus 1, plus 1. And then on the right-hand side, 5x minus 2x. We have it over here. We have 5 x's minus 2 x's. You only have 1, 2, 3 x's left over. 3 is equal to 3x, and then you have your minus 2 there. You have your minus 2. So normally if you were to do the problem, you would just have to write what we have here on the left-hand side. So what can we do next? Remember, we want to isolate the x's. Well, we have all of our x's on the right-hand side right here. If we could get rid of this negative 2 off of the right-hand side, then the x's will be alone. They'll be isolated. So how can we get rid of this negative 2? Or if we visualize it over here, this negative 1, this negative 1. Well, we could add 2 to both sides of this equation. Think about what happens there. So if we add 2, so I'm going to do it like this, plus 1, plus 1. So you can literally see we're adding 2. And then we're going to add 2 to the left-hand side, 1 plus, 1 plus. What happens? Let me do it over here as well. So we're going to add 2, we're going to add 2. So what happens to the left-hand side? 3 plus 2 is going to be equal to 5, and that is going to be equal to 3x minus 2 plus 2. These guys cancel out, and you're just left with 3x. And we see it over here. The left-hand side is 1 plus 1 plus 1 plus 1 plus 1. We have 5 ones, or 5. And the right-hand side, we have the 3 x's right over there. And then we have the -1, -1, +1, +1. -1, these cancel out. They get us to 0. They cancel out. So we're just left with 5 is equal to 3x. So we have 1, 2, 3, 4, 5 is equal to 3x. Let me clear everything that we've removed so it looks a little bit cleaner. Let me clear that out. And then let me clear, these are all of the things that we've removed. Let me clear that out. And then let me clear that out like that. Edit, clear. So now we are just left with 1, 2, 3, 4, 5. Actually, let me move this over. So edit, cut, edit, paste. So I could just move this over right over here. We now have 1, 2, 3, 4, 5. These are the 2 that we added here is equal to 3x's. These guys canceled out. That's why we have nothing there. Now, to solve this, we just divide both sides of this equation by 3. And this is going to be a little hard to visualize over here. But if we divide over here both sides by 3, what do we get? We divide the left by 3, we divide the right by 3. The whole reason why we divided by 3 is because the x was being multiplied by 3. 3 is the coefficient on the x. Fancy word, it literally just means the number multiplying the variable, the number we're solving, the variable we're solving for. So these 3's cancel out. The right-hand side of the equation is just x. The left-hand side is 5/3. So 5/3, we could say x is equal to 5/3. And this is different than everything we've seen so far. I now have the x on the right-hand side, the value on the left-hand side. That's completely fine. This is the exact same thing as saying 5/3 is equal to x is the same thing as saying x is equal to 5/3. Completely equivalent. Completely equivalent. We sometimes get more used to this one, but this is completely the same thing. Now, if we wanted to write this as a mixed number, 3 goes into 5 one time with remainder 2. So it's going to be 1 2/3. So it's going to be 1 2/3. So we could also write that x is equal to 1 2/3. And I'll leave it up for you to actually substitute back into this original equation and see that it works out. Now, to visualize it over here, how did you get 1 2/3? Let's think about it. Instead of doing 1, I'm going to do circles. I am going to do circles. Actually, even better, I'm going to do squares. So I'm going to have 5 squares on the left-hand side. I'll do it in this same yellow color right here. So I have 1, 2, 3, 4, 5, and that is going to be equal to the 3 x's. X plus x plus x. Now we're dividing both sides of the equation by 3. We're dividing both sides of the equation by 3. Actually, that's where we did up here. We divided both sides by 3. So how do you do that? Right-hand side's pretty straightforward. You want to divide these 3 x's into 3 groups. That's 1, 2, 3 groups. 1, 2, 3. Now, how do you divide 5 into 3? And they have to be even groups. And here, the answer tells us each group is going to be 1 2/3. So 1 2/3. So it's going to be 2/3 of this next one. And then we're going to have 1 2/3. So this is 1/3. We're going to need another 1. So this is 1 1/3. We're going to need one more third. So it's going to be right here. And then we're left with 2/3 and 1. So we've broken it up into 3 groups. This right here, let me make it clear. This right here is 1 2/3, 1 2/3. And then this right here, this is 1/3. That's another 1/3, so that's 2/3. And then that's 1 right there. So that's 1 2/3. And then finally, this is 2/3. And this is 1, so this is 1 2/3. So when you divide both sides by 3, you get 1 2/3. Each section, each bucket is 1 2/3 on the left-hand side. Or 5/3, and on the right-hand side, we just have an x. So it still works, a little bit harder to visualize with fractions.
And we'll take a look at example number 2 here from YouTube as well.
We have the equation 20 minus 7 times x is equal to 6 times x minus 6, and we need to solve for x. So the way I like to do these is we just like to separate the constant terms, which are the 20 and the negative 6 on one side of the equation. I'll put them on the right-hand side, and then we'll put all of the x terms, the negative 7x and the 6x, we'll put it all on the left-hand side. So to get the 20 out of the way from the left-hand side, let's subtract it. Let's subtract it from the left-hand side, but this is an equation. Anything you do to the left-hand side, you also have to do to the right-hand side. If that is equal to that, in order for them to still be equal, anything I do to the left-hand side, I have to do to the right-hand side. So I subtracted 20 from the left. Let me also subtract 20 from the right. And so the left-hand side of the equation, 20 minus 20 is just 0. That was the whole point. They cancel out. Don't have to write it down. And then I have a negative 7x, just gets carried down. Negative 7x. And then that is equal to the right-hand side of the equation. I have a 6x. I'm not adding or subtracting anything to that. But then I have a negative 6 minus 20. So if I'm already 6 below 0 on the number line and I go another 20 below that, that's at negative 26. Negative 26. Now the next thing we want to do is we want to get all of the x terms on the left-hand side. So we don't want this 6x here. So maybe we subtract 6x from both sides. So let's subtract 6x from the right, subtract 6x from the left, and what do we get? What do we get? The left-hand side, negative 7x minus 6x, that's negative 13x, right? It's negative 7 of something minus another 6 of that something is going to be negative 13 of that something. And that is going to be equal to 6x minus 6x, that cancels out. That was the whole point behind subtracting negative 6x. And then we have just a negative 26 or minus 26, depending on how you want to view it. So just negative 13x is equal to negative 26. Now, our whole goal, just to remember, is to isolate the x. And we have a negative 13 times the x here. So the best way to isolate it is if we have something times x, if we divide by that something, we'll isolate the x. So let's divide by negative 13. Now, you know by now, anything you do to the left-hand side of an equation, you have to do to the right-hand side. So we're going to have to divide both sides of the equation by negative 13. Now, what does the left-hand side become? Negative 13 times x divided by negative 13. That's just going to be x. You multiply something times x divided by the something, it's just going to be, you're just going to be left with an x. So the left-hand side just becomes an x. X is equal to negative 26 divided by negative 13. Well, that's just positive 2, right? A negative divided by a negative is a positive. 26 divided by 13 is 2. And that is our answer. That is our answer. Now let's verify that it really works. That's the fun thing about algebra. You can always make sure that you got the right answer. So let's substitute it back into the original equation. So we have 20 minus 7 times x. X is 2. Minus 7 times 2 is equal to 6 times x. We've solved for x. It is 2 minus 6. Minus 6. So let's verify that this left-hand side really does equal this right-hand side. So the left-hand side simplifies to 20 minus 7 times 2, which is 14. 20 minus 14 is 6. That's what the left-hand side simplifies to. The right-hand side, we have 6 times 2, which is 12, minus 6. 12 minus 6 is 6. So they are indeed equal, and we did indeed get the right answer.
All right, let's go ahead and take a look at our independent practice problems for today. Here is example 1. It says Marshall's work for solving x plus 2 times the quantity of 3x minus 4 equals 2 plus 5x is shown below. Between which two consecutive steps did he make a mistake? Go ahead and pause the video to take a minute to look at the problem here, and we'll get to the answer in just a moment. Let's go ahead and look at our solution.
All right, let's look at example number 1 from day 4. So here we're getting into multi-step equations that can include distributive property, combining like terms, variables on both sides, or all of the above. All right, so with this problem, it says Marshall's work for solving this equation is shown. They want to know between which 2 consecutive steps did he first make a mistake. So we're going to work it out step by step and see if we can find where the mistake was. All right, so the first step is always to take care of the distributive property if we have it. So we do have the distributive property here. This positive 2 is going to need to be distributed to that 3x and to that negative 4. So x is going to drop down up front, and we're going to take care of this distributive property. So positive 2 times positive 3x is a positive 6x. And then positive 2 times a negative 4 is a negative 8. On the right-hand side, there's no distributive property, so we're just going to bring down what we have, 2 plus 5x. All right. As you can see, that matches step number 2. So he did not make a mistake between step 1 and 2. Then the second step is to combine like terms. So first we'll look on the left-hand side. On the left-hand side, we can combine this positive 1x, right? If there's no coefficient, it's a 1. So positive 1x and positive 6x makes a positive 7x minus 8, and then equals 2 plus 5x. No like terms over there. One has an x, one does not, so we're just going to bring it down. So if you look at step number 3, that's exactly what Marshall had. So he did not make a mistake between 2 and 3. All right. Then we need to get all variables to one side of the equation. So as you can see, he put all of his variables over on the left side. All right. So in order to get all the variables to the left, I would have to move this positive 5x over here. So to move it, I need to do its opposite. So opposite of positive 5x is a minus 5x. Because we're solving an equation, what I do to one side, I do to the other. And make sure you line up your like terms. The minus 5x should not be under this 8. All right. So 7x minus 5x, that's going to be 2x. We bring down the minus 8 equals, the 2 just drops down, and 5x minus 5x, well, that's a 0 pair. So we're left with 2x minus 8 equals 2. And that's what he has on his next line. 2x minus 8 equals 2. So no mistake there. After all variables are to one side, we want to undo addition and subtraction. So attached to this x, we have a minus 8. The opposite of a minus 8 is a plus 8. What we do to one side, we do to the other. So here we have a 0 pair. So what's left on the left side is 2x. And on the right, 2 plus 8 is 10. But look at what Marshall has at step number 5. He has 2x equals negative 6. So it looks like what he did is he put a minus 8 on both sides because 2 minus 8 would be negative 6. But a minus 8 or negative 8 will not undo a negative 8. He forgot to do his opposite. All right. So the mistake was between steps 4 and step 5. So the correct answer is between step 4 and 5, but let's just finish working out this problem. So this is x times 2. I'm going to divide by 2. So the correct final answer should be x equals 5. All right. So his first mistake, so this line was wrong too because he got x equals negative 3. But his first mistake was between steps 4 and 5 because that's where he had his first wrong answer. He had 2x equals negative 6, not 10.
And let's move on to example 2. It says, what value of x makes this equation true? 5x plus 8 plus 3x equals 26 plus 6x. Go ahead and solve and check your answer for that one as well. You can pause the video so that you can have your own time to solve the problem. And going to our solution, Here is our solution for example number 2.
All right, so let's look at the solution for example number 2. Here we wanted to find the value of x that makes the equation true, so it's asking for the solution. What is x equal to? All right, so with all multi-step equations, we're always going to look for the distributive property first. This problem does not have that. So then we go to try to combine like terms on both sides of the equation. So if we look on the left side, we do have terms that we can combine. We have a positive 5x that can be combined with a positive 3x. So 5x's plus 3x's make 8x's. What's left is the plus 8. On the right-hand side, we have a 26 and a plus 6x. Those are not like terms, so we just need to bring them down. After we have combined all like terms, we want to get all variables to one side. Now you can move the 8x's over here or the 6x's here, it doesn't matter. I'm going to move the 6x's to the left to get all the variables on my left-hand side. So the opposite of a positive 6x is a minus 6x. What I do to one side, I must do to the other and line up your like terms. So 8x's, take away 6x's, we're going to have 2x's left over, plus 8 equals, we have 26, and then 6x minus 6x, that's a 0 pair, so we just have 26. From there, we're going to undo addition and subtraction, so the opposite of plus 8 is minus 8. What we do to one side, we do to the other. 8 minus 8, that's a 0 pair. So we have 2x on the left side, drop down your equal sign, and 26 minus 8 is 18. From there, the x is being multiplied by 2. The opposite of times 2 is divided by 2. 2 divided by 2 is 1, so that's 1x, or just x. And 18 divided by 2 is 9. All right. To make sure we have the correct answer, we should check. All right, so I'm going to rewrite the problem and then plug in that 9. All right, so I have 5 times 9 plus 8 plus 3 times 9 plus 26 plus 6 times 9. All right. So we use order of operations when we're simplifying these expressions on each side of this equation. So we'll work on the left side first. So 5 times 9, that's 45, plus 8, plus 3 times 9, that's 27, equals. Then on the right side, we have addition and multiplication. So we can do the multiplication on this line. So 26 plus 9 times 6 is 54. All right, then addition and subtraction left to right. So 45 plus 8 is 53. Bring down the 27. We didn't use that yet. And 26 plus 54 is 80. Then on the left side, 53 plus 27, that's 80. 80 equals 80. That means my solution of x equals 9 is correct.
We've got one more example here for today. It asks what value of a makes the equation true. So we have 7a plus 6 equals negative 5 times the quantity of a minus 6. Go ahead and pause your video here and take a moment to solve and check your work before you move on to check the solution. And here is our solution for example 3.
All right, here we have our last example for today. So let's go over the solution. So first step, always to look for the distributive property. On my left side, I do not have the distributive property, so I'm just going to bring that down, 7a plus 6. On the right side, I do have the distributive property. So this negative 5 is going to be distributed across those two terms. So a negative 5 times a positive 1a is a negative 5a. And then a negative 5 times a negative 6 is a positive 30. From there, I look to combine like terms. On my left side, these two cannot go together. On my right side, those two cannot go together. So I move on to the next step to get all variables to one side. So again, I'm going to move my variables to the left. So the opposite of negative 5a is a positive 5a. What I do to one side, I'm going to do to the other. 7a's plus 5a's is 12a's. Bring down the plus 6, did not use that yet. Negative 5a's plus 5a's, that's a 0 pair. So we're left with a positive 30. From there, we're going to undo addition and subtraction. So the opposite of plus 6 is minus 6. We have a 0 pair again there, 6 and negative 6. So what's left is 12a equals, and then 30 minus 6 is 24. A is being multiplied by 12, so we're going to undo multiplication by dividing by 12. 12 divided by 12 is 1, so that's 1a, or just a. And 24 divided by 12 is 2. So a equals 2. Because we are good math students, we're going to check our work. So we're going to copy down the problem. Substitute in what we believe the answer is. So 7 times 2 plus 6. Does that equal negative 5 times 2 minus 6? All right, so using the order of operations, on the left side, multiplication comes first, so 7 times 2, that's 14. Bring down the plus 6. On the right-hand side, order of operations, what's in parentheses goes first, so 2 minus 6 is negative 4. So I have negative 5 times negative 4. Back on the left, 14 plus 6, that becomes 20. And negative 5 times a negative 4 is also a positive 20. That checks, meaning that my solution of a equals 2 was correct.
Here is your practice and homework for today. Go ahead and show your work and keep it so that tomorrow when we go through the next lesson, you'll be able to check your work there. And like we ask you every day, please log into Dreambox through Clever and complete at least one lesson. Remember, you should be completing at least 5 lessons a week. That is our goal. Dreambox is connected to your MAP score, so everything that is on there is tailored perfectly towards you and the things that you need to work on the most. Have a great day.